Selective breeding is a straightforward process in which humans intentionally choose which organisms to mate based on desirable traits they wish to enhance in future generations. This practice has been used for thousands of years in agriculture and animal husbandry to produce crops with better yields, livestock with more meat or milk, and pets with specific physical or behavioral characteristics. The method is simple because it involves selecting parent organisms that exhibit the preferred traits and breeding them together, with the expectation that their offspring will inherit those desirable characteristics. The simplicity of selective breeding lies in its direct approach. Farmers and breeders observe the traits in their plants or animals, such as faster growth, greater resistance to disease, or specific physical appearances, and choose those that best meet their goals. Over successive generations, the selected traits become more pronounced in the population, as the offspring that inherit these traits are themselves bred to continue the cycle. This process can lead to significant changes in a species over time, making it a powerful tool for shaping the characteristics of domesticated animals and cultivated plants. However, the main drawback of selective breeding is the reduction in the gene pool, which refers to the variety of genes within a population. When breeders focus on specific traits, they often use a limited number of individuals as breeding stock, which can lead to a decrease in genetic diversity. This reduction occurs because the same genes are repeatedly selected, while others are excluded from the breeding process. Over time, this can result in a population with a narrower genetic base, making it more susceptible to certain problems. One significant issue associated with a reduced gene pool is an increased risk of inherited diseases. With fewer genetic variations, harmful recessive genes that might cause disease can become more prevalent. For example, in dog breeding, certain breeds are known to suffer from specific genetic disorders because the gene pool has been narrowed through selective breeding. Additionally, a reduced gene pool can make a population less adaptable to changes in the environment, such as new diseases, pests, or climate conditions. Without genetic diversity, the population may lack the necessary traits to survive in the face of new challenges, leading to potential declines or even extinction. Selective breeding, while simple and effective in achieving desired traits, carries the inherent risk of reducing genetic diversity within a population. This reduction in the gene pool can have serious consequences, including an increased likelihood of inherited diseases and decreased adaptability to environmental changes. Despite these risks, selective breeding remains a widely used and valuable practice in agriculture and animal husbandry, though it requires careful management to avoid the negative effects associated with a diminished gene pool.